we want to help decision makers to make better decisions, but
Yeah.
we don't want to make the impression that we are doing some magic. It's a science, and it's not point estimate, it's a range.
Hello, everyone. Welcome to the Data Scientist Show. Today we have Rami Krispin. Rami leads the data science and engineering team at Apple Finance Decision Support. He uses advanced statistical and machine learning models to help leadership make better decisions. He is also an open source contributor and the author of hands-on time series analysis with R and several R packages for time series analysis and machine learning applications. He has a master's degree in applied econometrics. Today, we'll talk about time series, open source, MLOps, and his career journey. If you have been enjoying the show, subscribe to the channel, and I appreciate it if you give me a 5-star review. Welcome to the show, Rami.
Thank you for having me here, Liliana.
You have a background in econ, actual science. How did you get into data science?
That's a long story. Back then, when I was in my second year of my degree, I had to kind of like start to look the path where I want to go. And a friend told me that his friend from Mentees is looking for a data scientist to his team, and asking what is a data scientist. I didn't know. It was not as common today. And I bought a book. I started to read about it, and you mentioned it's a lot of regression analysis, classification, building models, and it was feel like what I learned in economics and actual science, all the statistics.
Yeah.
And from there, I got thinking into it. I bought the book, Introduction to Data Science. I still feel it's a very common book that give you the kind of like the concept.
Mm-hmm.
I got really deep into it, and here we are.
Yeah. So you already have a background in statistics from your previous degree, and then you learned more hands-on experience from just self-learning, including like coding, machine learning.
Yeah, and while I was the student, I worked in several research assistant roles that required me to code a lot. So, I started with in the econ department, where I got exposed to Stata, which is very common in econ.
Yeah.
Less common in industry-wise. But then some professor told me, maybe you should look at R. And I took the very common course in Coursera by John Hopkins. And from there, I started to apply it on my research assistant work. And by the time I graduated from my degree, I had a decent programming background that I could start work as a data scientist.
Okay, yeah, thanks for sharing that. And can you tell us what did you do in your first job as a data scientist?
Yeah, so after my graduation, I started to work at Ernst & Young, the consulting company, at the advanced analytic section. There was, that's one of the great things about working in consultant, that it's very flexible. You are moving from projects, and I got exposure to different domain areas. So the first was I built classification models for fraud detection for a large automobile company that was our client. And then I got into forecasting. So my second big project was developing forecasting models with time series, traditional statistic and machine learning models. And this is where I took my academic background. I had just a basic academic background and got into it. And for 1 year, I just spent on developing models. And that was kind of like where I can say I fell in love in time series.
Yeah.
And since then, I'm doing a lot of time series. That's where I started.
Yeah. I think my first project is also time series. I think people don't talk a lot about time series, but it's actually very useful. And it doesn't have to be very complicated when you just start it. If you just start thinking about trends, it could be a linear model and plus seasonality. So I'm curious, comparing your first time series model versus the time series model used today, what has changed?
I think I went through the journey that most of the data scientists go, at the beginning that try to do complex stuff,
Mhm.
to throw XGBoost, to throw deep learning.
Yeah.
And over time, you realize that for the simple problem, if linear regression could do the same work, if not better. I use the approach that when I develop time series models, I do horse racing between multiple approaches, depending on the context and the business problem and the type of the data. Evaluate which one work better using backtesting, which is the time series equivalent for the machine learning cross-validation. And based on kind of like the experiment that I'm doing with the data, I can decide in production what are the main models that I'm going to focus and scale it up. Typically, it's not just forecasting one time series, but is hundreds, if not more.
Yeah. And you mentioned the back testing, which is equivalent to cross-validation and other machine learning methodologies. Can you share a little more about the best practices around it?
Yeah. So backtesting, essentially, it's you splitting the data into multiple training and testing partition where, like in machine learning, you are training on the training and evaluate the performance on the testing. The main difference that time series is sequential data. You're not doing a random splitting.
Yeah.
Technically, you can do in some condition, but in most cases, you don't want to do random, but do some window function that go split into different training and then leave some room for testing.
Mm-hmm.
And based on this, you can evaluate how couple of things. First, you want to evaluate how the model perform with the data that the model didn't see in the training. So it gives you indication how well the model will perform in the future, in the actual forecast. The other thing that you want to evaluate is, in some cases, your data is keep changing. Some of the structure could be some event or structural break, and you want to see which model can handle changes best. So it's also depending on the context, but there's some use case that you can benefit from backtesting.
Mm-hmm. Yeah. And in terms of time series data, you mentioned the data can often change. And how do you handle, data drift?
Yeah, so there are in time series, so time series come with what we call the structural or the built-in components, which is the trend you mentioned before, the seasonality. And the rest is usually the random component is all the things that are not filled by the seasonality and the trend. And there is common changes in time series could be that you have a shock, structural break. So let's say a COVID, you saw what happened to the unemployment that you see a structural shift up.
Yeah.
And then you can add some variables like indicator that will tell the model, hey, from this point, there is a new state. Let's take into account. This is where regression come very handy, and the traditional time series model, it's out for them to, the one that cannot get inputs, they just use strictly the historical. This is where they typically will fail. Could be special events, outliers, that you also want to flag them with the flag indicator, 1 out 10 coding. And it could be that you have a seasonal events that occur multiple, once a year or more than once in a year, but not necessarily at the same time. And a good example is Easter. Easter occur every year in a different date, as opposed to Christmas, which occur
right
24 is the eve, 25 New Year Eve is the 31st and 1st of January. So this is where it's you want to use some indicator. There is other more complex methods, but that's kind of the in nutshell the methods.
Yeah, in my first project, I work for a company that dealing with airport traffic. So we need to look at Thanksgiving. And like you mentioned, it's a certain week of the year. It's not a specific date. So I think when we took measure of the data, you need to do some transformation, and some part of it you need to change to like which week it is instead of a certain day. Sometimes you just wish, can you just define all the holidays on a specific day of the year?
It would be
that will make data science life so much easier. And also like daylight saving. I don't know if does that affect
that's
time
a
series?
painful when you have hourly data and then you suddenly see like a day that your data is dropping to like 1 hour, it's dropping to zero because this is like the debt. And again, like there are ways to handle it. There is leap year, which is annoying. At least it used to be annoying in the old format that I used in R. Today it's much more easy to handle it with the different classes.
Yeah.
There are a lot of caveats and small stuff, but it kind of like you learn it really fast when you work with the data. I wrote a package about taking data from SFO passenger. So if you are into airports and travels, there is a nice time series data. It's typically like the academic data that it's really, you see like the nice seasonality. And if you want to learn how to model, it's a good place to start until COVID hit the world, and then you see like the drop in the number of passengers. And this is another topic, like how to model shocks, and this is, the uncertainty is increasing, and now you handle stuff that you cannot derive from your past data, your historical. So it's an interesting problem.
Yeah, can you tell us more about this problem?
So there is some cases that like if you look at the passengers data in not necessarily flights, but trains and this type of problem, you will see that the COVID, there was a significant drop. So typically you will see the drop and then there is some recovery. I didn't look at the data in the last few months. I guess there is some recovery, but still it's not going to the normal state. So there are a couple of things depending on the business problem that you are trying to solve. I feel like that in the context, if I would be the airlines company, I would want to know how much I lost. So you can go and the point before the COVID hit, do a forecast of the pre-COVID and take the actuals and do the diff. So we kind of like estimate of how many revenue you lost. You want to know when, like in the case that, we cannot know how the COVID will continue to affect.
Right.
So it's very hard to predict, but what you can do, you can help to build scenario case, like what if, and this is where you can use different splines to add to the data and to simulate
different splines?
Yes, splines regression.
Yeah.
And essentially it's like you are learning, let's say that you have a curve that's going down. So you learn how the velocity of the curve.
Okay.
And if you add a breakpoint, so you can start learn the recovery, but then the recovery could be long or short.
Yeah.
So you can say, I learned the slope down and up, and I want to say that the recovery up will take few months or years. And based on this, you set your spline. So you can build different scenarios and provide, in this case, it would be the airlines company that would want to know like how it's going to affect, for example, their revenue, how much they need to invest in aircraft. Then I can think about any other scenario. You can provide multiple scenarios about how would it affect without really know the data. It's more like business insight. So this is where I feel like the integration between data scientists and business analysts is the point that you build models that not necessarily derive out of data, but from insights.
Yeah. Yeah, thanks for sharing that. And I think it's interesting you mentioned that you go back to look at the data and compare to see what's the impact. I think when you solve those type of problems, your background in econometrics definitely comes in, and that's helpful because you have to think about certain causal relationships. It's hard to evaluate causal relationships. So can you tell us how do you combine causal inference and time series in order to drive insights, especially try to understand what actually happened?
Yeah, so I feel like regression is my first to go, that where you, for example, if you have let's say that you have some data set that you have some shock, and you want to measure the shock. So running a regression, having some flag variable that you put 0 elsewhere, and just in the shock you set it as 1, and then you can quantify the weight of this shock. And you can go to the decision makers and say, if I will have this shock in the future, that's how I feel the impact could be. Now there is more color for this. You can check the when you're running regression, you get the standard deviation, and you can do some simulation and give range. This is another reason I love regression that enable you to do not just point estimate, but also give range. And I feel like as a data scientist, always I feel like that you should never build prediction without prediction interval. That's
confidence interval.
Yeah, because this is it's you educate people to think that you are doing magic, and we are not. We are well, there is some limitation for what we can do. We want to help decision makers to make better decisions, but we don't want to make the impression that we are doing some magic. It's a science, and it's not point estimate, it's a range.
Yeah. And I think that's a great point. And when I built my time series model, I remember the forecasting, the range is getting really wide, especially after a certain period. So how do you tackle that problem?
So this is where I feel like there's some models, like if you use linear model, it won't give you this impact.
Yeah.
Because the growth is of it's linear and doesn't take into account the time. If you use ARIMA, you will get this impact because the model take into account the variation that created by the time. Sometimes it looks scared for different stakeholders when they see a wide confidence interval, so they're getting wide. But I feel like that's kind of like if you expand, you are quantify the uncertainty that will occur as time passes by, it makes more sense, and it's hard to, accept it or live with it, as opposed to just, throwing these wide confidence intervals.
Yeah. And when we talk about causal inference, I think about experimentation. I think in grad school, I learned a method called longitudinal study. However, I never actually used that in my professional work. So I wonder, have you ever had projects where you design a longitudinal study or look at time series and then design experimentation using time series data?
No, I know longitudinal. I think that it's something I worked on when I was a research assistant. Since then I didn't have time or opportunity to work on such a problem. I'm more on the predictive side, like creating forecasts, but that's a whole topic by itself, and it's super interesting. I feel it's more related to experiment with trials, clinical trials, and I'm sure there are other area, but it's a super interesting problem.
Yeah. And in your book, Hands-on Time Series Analysis, I think the keywords are hands-on, because I remember when I was in grad school, when I learned time series, probably spent more than 60% of the time try to prove the ARIMA function, derive everything. And can you tell us what some specific advice or best practices you want to share in terms of applying time series in our projects?
Yeah, I feel like my approach when I wrote the book was nail down the stuff that I felt that was missing, which is the data. How you handle data.
Right.
Like most of the time we
don't need data. We just need a formula.
Yeah, people think that the data is there and it's just coming clean. But most of the time, I feel like most data scientists will spend about getting the data and cleaning it and understanding before the modeling. And the modeling is the easy part.
Yeah.
Once is also experience, but like modeling in this process is the easy part. I feel like the data is usually the challenge, and so I wrote out of the pain that I felt that I had in the past about the basic stuff, like when you are pulling data, how to reformat it, how to bring it to the format, how to aggregate it, how to read it, and this type of kind of like tricks about the timestamp and working with the time object. And so before talking about models, I just spend a lot of time talking about the different classes in R, and then moving to the models. And I also love to do the derive the models and write them from scratch. I feel like it's much more. I used to spend a lot of time in the past doing it. Unfortunately, today I don't have the time to go and derive any model that I'm working with. But I feel like it's super important
to understand the theory. Yeah. So now with deep learning, a lot of people also use recurrent neural network, LSTM, when it comes to time series problems. So how do you compare that to, ARIMA or regression models?
I think that this type of models, anything that is without, not the traditional time series models, their potentials is where you have a lot of features. And this is where I feel, for example, using regression, when you have 300 features, it's not the right way, because your ability to filter the features and doing some feature selection is limited. And where I feel that deep learning or basic regression, machine learning regression models could do better work. I feel this is where you want to try those type of models. One of the hardest thing to work with time series data, and I feel like it's a big misconception that you can just come, if you're trying to predict the electricity, usually when people ask you, did you use weather data or did you use temperature or anything like this? And in reality, you probably won't use it, because you need to forecast also this for your forecast. So
can you elaborate on that?
Yeah, so let's say that you have a time series of the consumption of electricity. Actually, I have a example that I built about the US electricity forecast, and you want to forecast the next month, hourly data. Now, weather playing big impact is impacting, there is a high correlation between the weather and the consumption. And if you really want to know, if you want to use it as the input, you need also to know what is going to be the weather in the next 28 days. And it's very hard to predict weather for the next 28 days accurately. So you're adding
a lot of noise.
And also there is a problem that you're typically, what people would do would train their models with the actuals and with actual weather data, but in the forecast, they will use a prediction that not necessarily has the same accuracy as the actuals. So you may add more noise to it.
Yeah, it's like if you want to use the data, you almost have to train some sort of kind of latent model, right? You're using whether I can use the weather from last month to predict some electricity, 1 month later, but not that same month. Yeah,
that's I feel like that in a short term, probably if you're using legs of weather that you still need to do the forecast.
Yeah,
it makes sense.
Right.
But once you need to create a forecast, and this is where it could be challenging and it could be like a project by itself to predict the forecast, the weather, temperature ones.
Yeah, that's such a good call out, because if you think about, I have some Kaggle project, I have all the data ready. I just need to split the data based on time using the backtesting method you mentioned. And I don't even need to think about whether the weather data is available, because it's there for the exercise. But when you're dealing with the actual data, sometimes maybe there are variables that are highly correlated to the variable of interest, but because of they won't be available in the time of production, so it's actually not very valuable to use that. As a data scientist, we always want to use as many variables as possible. Sometimes it's really hard to decide, I have to drop that.
Yeah, so I feel that's kind of like when you start, you have this, you imagine the world that you're going to have a lot of features, but you end up that you typically will create a lot of features out of the historical data.
Yeah.
And use this. as opposed to use external regressor as input.
Yeah, that's a great point. What are some other things that you think we need to pay attention to in time series?
Like ability to scale up. Typically today in most industry problems, you want to be able to scale up your problem. You may not have one series that you want to focus, so you need to think about how should you approach when you have, like in Kaggle, like the M5 competition is good example where they did a prediction of, I think, Walmart stores sales in 3 different states, and it's 1,000 of series. So if you're going to the route of, let's say, deep learning, that is a heavy computational process, you need to take into account that you're also going to need some computational resource that are expensive.
Yeah.
And the question that you need to ask yourself, what is the business problem that you are trying to solve? And does it justify to spend, like, what is, you need to think about the ROI of your model.
Right.
If it costs more than the value that it brings, then maybe it's not the right approach. But in there are some cases that accuracy, to be the most accurate is super important, and this is where maybe you should spend those resources. In other cases, just the business want to know the growth.
Yeah.
And you have like 10,000 or 100,000 series, so you probably want to think about also resources.
Yeah.
And
the ROI and the resources.
Yeah, and scaling up, I think is a very important thing to know in time series, because like as time passes by, time series, I feel like it's become like more common data format, because everything around us capturing data, all digital, and we have ability to observe a lot of data. We have less the ability to process it.
Yeah.
And time series is one of those examples. If I need to guess, time series is the most common data format.
It's also I don't know, maybe just my bias. I think it's the most fun because you can visualize that even before you do some analysis sometimes.
Yeah,
right?
I wrote a package just for data visualization of time series.
Okay. Tell us more about it.
It's the TS Studio. This is where I, back when I was at Ernst & Young, I had a goal to learn how to write package. I set it as a goal. And I felt like I'm working in one project, and I'm copying paste the function from the previous project. So I realized, why don't I take it as some kind of like a fun project for myself, generalize the process.
Yeah.
I use Plotly as the visualization, so it is interactive. And I started to build those functions. And I remember working for the first iteration. I feel like that, that's kind of like as a really junior data scientist, open source contributor that I feel like for a couple of months until I release something.
Yeah.
The second iteration I wrote on a 12-hour flight. And that's kind of like was like a big lesson learned for me, that don't try to make stuff perfect. They will never be perfect. It's better to have more frequent releases, get feedback from the community. It's part of being community. That's what great about the open source community. People will come and help you and guide you and provide feedback.
Yeah.
And it was a learning journey. I think a lot of stuff that I learned was by just writing code, building libraries, contributing to the open source.
Yeah, thanks for sharing that. I want to ask more about your contribution to the open source community later. And for now, can you tell us what was the data visualization library you created that's different than other, general data visualization library?
I feel first it was in most of the data visualization libraries for time series are based on the ggplot.
Yeah.
ggplot, I think it's one of the best data visualization period.
Yeah.
It's amazing. Like if you go and see hashtag Tidy Tuesday, what people are doing there, it's blown my mind. Like in the context of time series, when you're doing time series analysis, often you want to dive into the data, and this is and zoom in. Then this is the limitation of ggplot in my mind, that it's not interactive.
Mm-hmm.
And Plotly provide this functionality that, let's say that you have electricity data of hourly, and you will plot it in non-interactive. Your screen will be dense from points that it's very hard to understand. And if you just want to see one event, what happened there, or if you have some spike, you cannot. It's hard to do it just looking at the plot. You can see the range of the date, but with interactive, you can just hover and see the date and maybe do an additional dive in. So that's bought me.
Yeah.
And that was why I decided, I think since then, most of the packages that I wrote, I'm using Plotly for the exact same reason.
Yeah. What is the name of your package? Oh, we want to check it out.
So that package is, unfortunately, I stopped maintaining it because of a variety of reasons.
Yeah.
It's still there. It's still people down. I'm surprised when I see that it's still relatively.
Yeah.
I think there is last time I checked, there is between 3,500 to 4,000 people download it every month. That's TS Studio.
Yes, you.
When I started, my envision to build it as a interface that you can go, and a platform that you can do like visualization for time series. I never got the time to go and build it. So that was the inspiration of why TS Studio. Today I probably would call it in a different name. Today I also, this thing that you learn, I would do a lot of stuff differently. But it's there. It's supporting TS object, which is all the object in R, and some other format, which I feel like today it's less relevant. So if you're looking for other stuff, there are more modern stuff that's available there. If you're using TS objects, so probably that's the library that you want to use. If not, there is a more recent packages like TimeTK by Matt Dancho. It's a good library. There's a lot of functionality for visualization. Also with Plotly and ggplot, you can select your output. And there is all the good stuff that the folks from Monash University, led by Professor Rob Heinemann, doing the Fibble package and all this ecosystem. It's also a good place to look at.
Yeah, thanks for sharing. I was using ggplot for a time series project I was working on, like try to look at the seasonality of the rent price. That was my first tech blog I published on Medium. And I remember there was challenges using ggplot for time series data because of the grid. It's not by the seasonality. So I have to do a lot of processing divided by, the month, divided by 7, and it just doesn't look very pretty with the grid.
So I think there are some folks that create the extension especially for time series with ggplot that are really beautiful. Like that's what's nice about ggplot too, that you cannot beat how, for static plot, it's really hard to beat the beauty that you can do out of it. But if you need to do it from scratch, it could be challenging and more consuming.
Yeah. So you mentioned you set a goal to create a package. What made you want to set this goal?
I felt like when I got into the open source, when I started to learn R, I felt it's something, like if you want to learn how to write code in R, you need also to know how to write a package. I saw the value of having package. There was someone, David Robinson, is saying is one of the main contributors of R, said in the past, if you are using the same function 3 times, you probably need to write a package. So it's at the beginning, it seems to me like only the biggest contributors write package, but then like when I started, I realized it's so simple to write package. There's so many tools available, and I encourage people to go and write their own package and contribute. That's definitely a great experience.
Yeah. So when you coach people to write their own package, what is your best advice for them?
Start with simple. Don't try to, if you have a vision about where your package you want to have, doing it in iteration could be faster than try to make it, like the all features. Set milestones, clear milestones. It's very easy to, and from personal experience, to do like a scope creeping and become greedy to add more features. So if you have vision of what you want to do or what this functionality of this package, go to GitHub, your repo, create milestones, try to stick to those milestones, and do iteration. I feel like that's the main advice that would give to people that just starting to write package. Then the code quality will improve. Like if you don't have much experience, you will, like when I see now the code that I wrote like a couple of years ago, it's for me like, wow, this is junk. But again, like it's, I'm sure that if I will come in few years and see what the code I'm writing now, it will look at me like you want to have, that's how you measure yourself that you're improving. So go see what other folks are writing, what is the working, there is if you're in the R ecosystem, there is a great book by Idley Wickham. I feel that most of the folks that write packaging R went through this book. It's, I feel like it's, forgot the exact name, but it's the R packages, or the most trivial name for R package, for book about packages in R. So I recommend to go through this resource, and generally there are a lot of resources available. So just go and dive and just do it.
Yeah, just do it. And it's not as complicated as what you thought it might be. And then, like you mentioned, start small, and then release it, get feedback, and that's how you iterate.
Yeah. And make sure that you also share it with others. Like, if you're just creating package, but you're not doing the PR for the package, it's people not aware about what you're doing. And then like you're missing audience and missing feedback. So also make sure that you are promote your work properly.
Thanks for sharing that. And so previously you mentioned when you decide whether you need to take on the project, you look at the resources, look at your ROI. Sometimes it's difficult to measure the ROI before we dive into the project. So what are some strategies you use to think about the ROI of a project?
I think that generally it's derived from the business problem that you are trying to solve. Remember when I worked at Ernst & Young, there was kind of like you are constrained with number of hours, you are constrained with resources, and you need to figure out with those constraints how you make this project successful. So obviously when you have constraints, you need to scope your work accordingly, that make sure that you can deliver and not try to, it's this Dallas thing, I feel like, to do t-shirt size of your work and quantify like the time and the resource. But it's something that I guess that you can when you learn over time with experience.
Have you encountered situations where you took on the project, you thought it would be a good time series project or other machine learning project, but turn out it cannot be solved by data science?
Is typically you will understand in the beginning when you see the data, and I feel like that's my best advice for folks is not to commit. If you don't have the data they need, don't commit. We're not magician. We're not doing magic.
Right.
Do the limitation of if your data. I had a professor that used to tell us junk in, junk out, right? If your data is junk, your output will be junk. So make sure that you set expectation with the stakeholders.
Yeah. And what are some common mistakes people make in building time series solutions?
Wow, probably I did a lot of mistakes. I'm trying to think the stuff that I feel like in the beginning I was building a complex models that not necessarily, you need to, again, going back to when you're working in a business setting environment, you have a time limit and you need to deliver eventually the model. If your if you take any each time that you need to refresh your forecast, take like a 15 hours because you are trying to run some agreed search for tuning parameters on any possible parameter in the world just to get the best model. That's probably, again, the question, is it tie with your business problem that you are trying to solve? Like, does, if running it with a narrow grid search that will give you, let's say, 5% accuracy versus running it for 20 hours and give you 4.99, does this additional improvement worth the time that you spend or not? And I feel like that's where typically I fell in the past, and where most of the scientists, I see a lot of discussion about the accuracy in time series context. Like accuracy is important, but then again, like also computational. That's something that I feel that is missing when you are looking at a model evaluation metric. There's no like how much time it took to train the model.
Right.
I feel like that should be there. And what is the lift that it provides in accuracy?
Yeah.
So it should be like some kind of like a ratio between the accuracy and the time or the compute power that you spend.
Right.
And translate it into kind of like, does going between, like, let's say if your ratio is between 1.5 to 1.6, does increment improvement, does it worth it to spend the amount of compute that you or not? Again, it's tied to the business problem that you are trying to solve. There are some cases, I guess, that you really need to be accurate, and you throw all the GPU in the world to be accurate. In other case, that's you're not necessarily answering it's not answering the business problem that you're trying to solve. If you're just trying to understand what will be my trend in the next few years. So there is trade-off. You need to be able to not to fall into this trap of the accuracy or the trying to solve it with all the possible models and run it on like for hours on some server and not necessarily get the best results.
Yeah, I think that's a great point. I think I also wrote a post about sometimes it's worth to think about, is it really worth it for you to spend another 3 months to improve 1% of accuracy? Sometimes it is worth it. If you think about, maybe it's related to some medical cases or people's life. But sometimes if you're related to a marketing campaign, maybe if you launch today, that will drive more ROI to the business than improving, a few decimals after you spend more time and the resources. And I think keep this in mind. It's very important. I love that you mentioned have some type of ratio. Keep that in mind. And also it's difficult to decide when it's good enough. So for you, how do you decide when to stop?
Typically I have a timeline. You have a timeline when you need to deliver the result. So you kind of like need to derive it, and you don't want to spend the night before and then all the miracles happened when the model failed because the statistically didn't converge and throw some error and you need to go to debug. So you want to leave to derive your time, that you build a robust models that also can deliver within the time constraint. So that's the main advice here.
Yeah. And after you deliver the model, how do you maintain it?
This is, I feel like, where we are going to the MLOps. That's what drove me to learn more about MLOps. When you want to move away, just we need to refresh, and I want to run it locally on my machine and send some CSV. But you want to create some more automated and robust way to run the models. So if I need now to build a forecasting models, I'm typically in the mindset that it's need to go to production. It's need to be on according to production standards.
So when you start, you set a higher standard.
There is the development, which it's like a scratch when you're doing some kind of like a whiteboarding,
Yeah.
I would call it.
Right.
But then like once you kind of like figure out the best approach, this is where you need to think how to write code that could go to production. You'll be able to scale it, deploy it, and reproducibility, ability to repeat it, reproduce
Right.
results. It's very important.
Yeah, so I think sometimes data scientists kind of also have this trade-off, especially in the beginning of the project. You're vetting. Sometimes you're vetting a project. You don't know whether it will work or not. And for some people, they want to, maybe I can just write some scrappy code and then quickly find out whether it'll work or not before I commit to production. So versus I just always have a higher standard. How do you think about those two approaches?
That's a good question. I feel like that it's a personality thing.
Yeah.
I have friends that they will take the problem and, from the get-go, they will treat it as high standards, but sometimes that creates some tension when you have timelines. So like I always look first about when I need to. Sometimes there is like if you have some ad hoc request and you have a timeline, so trying to write the code as the most clean way might take more time and cause you to miss some deadline that you don't want. So I feel like it's a trade-off. I'm kind of like, if it's ad hoc, I treat it as ad hoc.
Yeah.
If it is, that's not ad hoc and this is where from the get-go it's like, let's write it the most elegant and clean, thinking about all the unit tests that you want to have and, it should live in some Docker environment and be able to deploy it.
Yeah, I agree. It depends on different cases, right? Sometimes time is a more important factor, or maybe the requirement for the code can be a little lower. You want to really deliver the insights. And sometimes for sure we're going to invest in the project. It will, maybe 80% go into production. Then let's have higher standard on the code to think about production, Docker, those environment. And when we talk about MLOps, what is something specific about time series models in MLOps that's kind of people need to pay more attention compared to general MLOps?
I can give a specific example from my our world. That when I moved to Docker environment, I realized that there are some applications that cannot work in Docker because the compilers, they are using some compilers that are not available in, let's say, Ubuntu. And that's cause problem. There is some very famous, I don't want to say the names, but there is a very famous library for forecasting that I feel from a big company that I feel that the authors, when they build it as a POC. I listened in the past to a podcast that the author, that's what he say, that it was never built for production, but then people are using it in production and you see it's falling apart. That's kind of like the BSTS library, Bayesian structural time series, is a unique package that I use a compiler. It's a Bayesian models that use underlying libraries that not available. The compilers are not available in Docker, so you cannot deploy it. And so at the beginning it was like, oh, I'm missing a model. But then over time I realized, okay, it's just, I have so many other models that can work and it's not the end of the world. And so like that's the thing that you need to think about on production. Can you reproduce it or not? There are some, like, I feel like that most of you need to look at the application that you use. And this is, I feel it's relevant for both R and Python, that most of the code is not native written in our Python. Like if you think about, let's say, TensorFlow, it's a good example, or Prophet, that they use C, TensorFlow, I think they use C or C++.
Mm-hmm.
So if you're using it in R, you're calling the Python calls that's not something you want to go into
Yeah.
production. So if you really want to use TensorFlow, probably you should not use the R version. You want to go to the, what is it? You need to ask yourself, is it the first citizen? Python is the first citizen, probably.
Yeah.
R is not. So in this case, I would not use R. So that's a thing that you need to think about when you start to think about production, how it will scale, how it will work in a different environment. Can you reproduce it? What are the dependencies and so on?
Yeah. And so when you put a model in production and then you can collect more data and to verify your model and measure the impact, can you share like how do you measure the impact of the model you built?
So typically, I think that the most important is to collect the data after the realization of the data and compare how the performance. And then you want to do some monitoring. Let's say that if you see that there is you set some kind of a threshold that if the accuracy of the model diverge for some range, you want to set alert and go check it. It could be that something happened with the data or some event triggering that that you went out of your prediction intervals and you want to flag it or go check it, or the model is just not working well. So just maybe you need to go and think again if the model that you use is the one that you want to use, or maybe retrain and with different approach.
Yeah.
So monitoring, it's very important.
And what are some best practices in monitoring time series models?
So if you have some type of scheduling system that you should write some code that you go and pull data and do some this kind of like the diff, compare with your actuals and do the comparison and be able to trigger alert whether if it's there is easy Slack as API or there are different systems that you can go and send notification. I actually in the recent days what I'm trying to work, so I have a project that I'm writing a example of how to deploy machine learning models in production for educational reasons with open source. I'm using the US electricity demand for electricity, hourly data, as example where I build infrastructure that use GitHub Action to pull the data from the API every hour, update the dashboard, create a forecast for the next 3 days of the consumption, and every 3 days to refresh the forecast. So the dashboard is refreshed every hour, the data, the forecast every 3 days. And now what yesterday I was struggling, and then I posted before in this morning about for help in Twitter, if anybody know how to, I want to do the monitoring with Twitter. So whenever there is a diversion in the forecast, to shoot a Twitter. Tweet about it and say the forecast, there is some outlier, or to shoot an image. So I'm, yesterday I just got the approval for the Twitter API, not the V2, the V1.1. You need to enroll and get some approval from Twitter. And that's what I'm working now, how to exact the same problem, how to upload when you generate the forecast. I want to create the ability also to take the image and tweet it and say, this is the forecast for the next 3 days. And also one of the things that I'm measuring is the accuracy. So whenever you are diverged from the accuracy, to shoot it to Twitter and say, hey, the model is not working. Or maybe there is high consumption. Maybe, it's a odd day or something, or, or cold or so.
Yeah, that's very interesting. What are some other, fun project or open source project you worked on?
So I want to say it's fun. But fun is probably not the right word.
Or
it's more
just
interesting.
Interesting, yeah.
It's the COVID-related project. So I feel like now we're in February. 2 years ago, it's when I started when the pandemic was only February 2 years. I remember I was traveling with my kids to Disney World, and you start to see people with masks, and it was it's still not here in the US, and or not really. There was more like in China and then Italy. So I realized that it might be there is a time series here. So I started to build a package.
Yeah.
At that time, the name of the pandemic was coronavirus.
Mm-hmm.
They changed, I feel like, a few months into the pandemic to COVID-19.
Yeah.
And so it was a big project that started with, I thought maybe it's a time series. It could be because I'm in time series. I love to work with time series. I started to script the John Hopkins repository and create a tidy format for the data. And I realized really fast that it's probably, it's not something for time series analysis or forecasting. It's pandemic, and I saw people doing stuff, and I felt that it's not my domain. There's one thing to predict electricity, but predict the pandemic, it's not. I didn't have the domain knowledge. I feel like there is a lot of misconception about it, so I didn't want to be part of it. But I wanted to help to scientists or other folks that want to have access to the data and to the clean data. So it started with the coronavirus, where I feel like when I learned a lot of stuff about MLOps because of the coronavirus, because the first days I used to refresh manually the data every night. At the beginning, I didn't realize that it's going to be so long. Like we had 2 years, we're still into it. And I learned that's when I learned about GitHub Action. I learned how to build automation, how to build pipelines with open source tools. That was a really fun experience to learn it. The one thing and it's developed to other libraries for COVID-19 data, and build on top of it also dashboard that automate every day. So, and it's one of the things that I'm proud of it. It's like that, it's there for now close to 2 years.
Yeah.
From the moment that I reached to some level of maturity and it's in production, it's work like a Swiss clock. It's every day it's refresh. It's no errors, nothing. It's there, no maintenance. So was I feel like that's the experience from, again, like another example of experience that you can gain from open source.
Yeah. And it seems like you're not thinking about, I create this project for my portfolio. You just genuinely want to learn. You're curious to solve this problem. It's like playing video games to you.
Yeah, I feel that when I started to go to the open source, so I was curious, but I also want to build a portfolio. When you come in without experience, I realized that I need to have something to, I felt, we can talk about it later, but like when I started to apply for roles, I applied for all over and nobody reached out and back or aired back. And then like when you interview it, I feel like it's very hard to, to pass those interviews because the expectations are different and the mindset is different. So I felt like if I want to kind of like overcome this struggle of getting interviews, I need to rebrand myself.
Yeah.
And open source seemed like I was curious about open source, and it was there. It's right there at the time that I discovered it, and I got into it. It's like entering to some kind of black hole. It's it sinks you inside, and you cannot get out of it. And now I'm enjoying it. I don't need to, I feel like I'm in a position that I don't need to prove anything that about knowing stuff, and I'm enjoying, and I'm trying to learn new stuff, like doing Twitter, like using GitHub Actions to shoot alerts about stuff with images and stuff like this. Is like fun.
Yeah,
it's pure fun.
Yeah, thanks for sharing that. And now, from struggling to find a job, you become a manager. So when you hire people, do you look at their open source contribution if they have something?
I mainly look the people So generally, not specifically talking about my work, but generally, I feel like that people should look at the first thing that you need to look at is a passion
Yeah.
for what you're doing.
Mm.
You want to find people that they have a passion for statistics, for data science, for
Yeah.
data visualization, depending on what you're looking. People that doing it and enjoying it.
Yeah.
I feel that's what I'm looking. Having open source, it's one way to see that if people are doing open source, they probably love it. There is other ways. Not all people are open source, and I know many great people that are not open source contributor, but they are still have a passion and they're doing stuff, amazing stuff. So there is more to it. But having when nobody, like when you're getting hundreds of resumes, you need something in addition to this resume. If you're writing a blog, it's a great thing that you can see what the person is doing. If you're doing some code challenge or anything that people do, I always, when I see junior folks that doing all those code challenge, I really enjoy it to watch what they're doing, and they have a passion.
Yeah.
It's a fun thing to have.
Yeah, thanks for sharing that. I think it's hard to measure passion, but if you showcase your work through your GitHub, you write a blog post or your open source contribution, that is showing that you're passionate about what you do, besides doing homework and doing exams. So besides passion, what are some other things you look at when you hire people?
I think it should be like a general fit for the role and culture fit. I always, the first thing I ask is the person that I want to have coffee with in the morning when I'm coming to the office, if I would go to the office, not in the pandemic, but generally, I feel like that's one question. And diversity. I feel like that in the beginning when I got hired, we were doing time series, a lot of time series, when I realized that we also want other capabilities and you want to surround yourself with diverse people.
Yeah.
You don't want to mimic yourself, definitely. You want to bring people that are better than you, smarter than you, and to create diversity.
Yeah, I think that's very important. And then when you do interviews on the technical side, what are something that you feel it's okay they made mistake or they don't know during the interview? What is something that you think it's coachable?
I feel like that I can take example for in R, and I'm sure Python is the same, or Julia or any other language, that you can do one thing and you can get to the same place with multiple approaches. And it's like something, for example, in R, there is, those groups, there is the tidyverse and there is the base R and there is the Fox. I think that, it's okay to do it as long as you can articulate why you're doing what you're doing. And if, for example, I'm gravitating more toward, for example, the base R, and I'm using, tidyverse, but I'm not fanatic. And when I see people that are not, sharing the same perspective like I do, as long as they can articulate, I don't expect, everybody will, follow the same logic. People, there is not just one way to do stuff. So as long you can articulate why you're doing, or you can say, this maybe I don't know, but I can check, or that's fine.
Yeah. Thanks for sharing that. And what are something that you feel, data scientists must know, and if they miss certain quality, that would be like a red flag?
I feel like that you need to, the main thing is like, again, data science is a very vague term. I feel like today I can, definitely think that is a very vague term. So depending on the context, so if the data science that you're looking is a data visualization, so you probably want to, if it's not a person that is expert in statistics, that's fine. But if it's someone that needs to build models, I feel like that if the person doesn't have background in statistics, math, or some basic linear algebra and it might be red flag, not necessarily. People can learn on the way, people can catch, but I feel it's also the foundation that you want to have: statistic, math, and programming, right? So in most cases, the expectation is person will have some programming knowledge, not necessarily expert, but depending on the job description.
Yeah. Thanks for sharing that. I think it's very important. You mentioned that data science is vague and it's very broad. It's very hard for us to hit every single mark. So I think it's important to, go to job boards like Indeed, LinkedIn, search like 20 jobs to see what is the most common required skills. For example, a machine learning engineer, you need to know machine learning. You definitely need to know like R, Python, one of them, right? But if you are looking for a more kind of BI type of position, maybe you only need to use SQL, or maybe just some data manipulation packages in Python. Maybe it's not required. So it depends on where you're starting and where you want to go. It's definitely important for us to learn everything. But if you're just starting or you're transitioning, I think it's important to prioritize, know what you need to learn, and know our time is limited, and be comfortable with the idea. Okay, those are the things I don't want to look at right now.
Yeah, definitely. You need to prioritize, and this is something that I always say. Many folks that reaching out in LinkedIn and ask me, I'm a student and I don't know where should I focus. Always, data science is a vague. You need to think about the field. It's how to make a decision. I didn't know which field I want to go. I just, in my first job, I landed on time series, and since then I'm there. But I try, multiple stuff, doing fraud detection, classification, and prediction, and then I landed on time series. But if you know what you want, go look for, like you mentioned, job description. Try to understand what are the main requirements. Try to filter like the core requirements. Identify gaps and go to learn them. Like you go to Coursera or any of those great resource, Free Code Camp, or any of those resources that available, and they're there waiting.
Yeah, that's a great advice. So you previously mentioned Julia. And how do you compare, R, Python, Julia?
So I feel like it's always the discussion that you see in the internet, R versus Python, or Python versus Julia, or R
it's
versus,
like a religion war.
I always feel like that you should use whatever works best for you. If you're doing statistics, probably R is a great tool. Today also Python. In the past, there was, in the beginning, R was born as a statistic ML language, but didn't have the ability to what we call the MLOps. And Python came from as a general programming language, and didn't have many statistical tools. But today, I feel like that both have the same, or you can find in both all those things. So I feel like this is more like where you feel comfortable, your needs. I think that Julia is the programming language of the future. If someone will come to me and ask me, I just started, I need to pick a language, I will be in the market in 2, 3, 4 years. Go learn Julia. If you can learn more, Python. But I feel like Julia is where, if I need to bet, I put my money. So Julia is the future.
Why is it the future?
Because it's solving the problems of Python and R. Python and R are slow languages, and in order to overcome that they are slow, if you want to make them fast, you need to go and write your code, your underline code with C or C++ or Fortran. Julia doesn't have this problem because I'm not a computer science, so I probably will defer it to someone like Logan to explain it. That was here. But the underlying code is all written in Julia.
Mhm.
So you don't need to go and, call other languages. It's solving the two languages problem that typically you have the upper language like R and Python. And then in order to optimize your code, you are going to the lower language, speak with the CPU
Mhm.
and memory with C, C++, and so on. So that's I feel like where Julia is shining. One of the things that you can, in order to think about programming language, about the success of programming language, you need to have like a minimum mass of people that contributing. And I feel Julia is there. There is now enough people that contributing to enable the exponential growth of the language. If you go and see what happened to R a couple of years ago, and the exponential growth in contribution, and similar to Python, I feel Julia is now there. So we meet in 4 years now. I feel like the main language for data science would be Julia.
Yeah. Wow.
If I need to guess,
Mm-hmm.
it still might be R and Python.
Yeah.
They're still great languages,
Mm-hmm.
but there are some advantages in Julia that I would say go for it. I'm going, so, I'm trying for a couple of years to learn Julia, couple of years, like last 2 years.
Mm-hmm.
And, one of the hardest things, like you cannot start to one day come to work and say anything I'm going to write with Julia, because, it's a time that typically you don't have. So I'm challenging myself by translating some of the packages I wrote in R to
translate that to
Julia. Yeah,
Mhm.
that's one way to learn stuff.
Yeah.
The other thing that I'm going to soon start to work on a book about time series that it's going to be in R, but I'm going to challenge myself also to write it in Julia.
Mhm.
And this is, I feel like, where the challenge would be, because some of the application that you have in R, you won't find them in Julia yet.
Yeah.
So it will be hard to there is the gap that you
Mhm.
need to, if you want to have like in parallel tracks. But it will be fun experience to see how you write this code in Julia. And going back to our discussion before about Plotly, so one other reason that I love Plotly, that it's agnostic. It's available in Python, Julia,
Mhm.
and R. And actually the code in Julia is much more elegant
Yeah.
for Plotly than in R. So it's another plus.
Yeah. Thanks for sharing that. Exciting to know you're writing another book, and it's a great way to learn things and master it by doing a project with it, writing a blog post or a book about it. So very excited to see that. And what do you think about the future of time series?
It seems like the world is going to machine learning, deep learning.
Yeah.
That's like if you go to Twitter, LinkedIn, that's where I feel like the world is going. I feel like when it will be there completely when today GPUs is expensive. I feel like in a couple of years it will be probably cheap like a CPU.
Yeah.
And when we get there, so I feel it will be dominant. A lot of application now is built by a lot of companies for using LSTM, RNN, and other applications, and the traditional machine learning like XGBoost. When you can run it fast, as you can run the traditional time series models, and with the same level of accuracy, I feel that's kind of like the future.
Yeah. What are some biggest challenges in time series today?
It's always start with the data. Is the getting the data is like I was looking yesterday about getting flights data on US. I remember there was a couple of years ago I saw in the Bureau of Statistics they had like a data set about all the flights it was a huge database and I couldn't find it. But finding the resource and the data is always been challenge. If you need to try to think what could be also be challenging with time series, it's again take it into translate business problem into time series into data science. I feel like it's a complex problem to define and narrow down the problem into the data that you need to solve it. It's typically challenging.
And what are some struggles you have faced in your career?
I would start with communication skills. I feel like
Mhm.
that's something I had to adopt and learn and improve. Still need to improve over time. And that's what drove me also to go to, like events like this, right?
Yeah.
I'm now challenge myself. I'm not native, person that can speak in this type of setting. To go to
Mhm.
lecture in a meetup, to run a workshop,
Yeah.
it's take me a lot of effort and
Mhm.
require me a lot of capacity of
Yeah.
and that's something I always I identify that I have a gap, and I'm trying to challenge myself whenever I can.
Mhm.
um and that's was I feel like when I started, when I finished my masters and I was going to the job market, it was a challenge for me to, you know my resumes will look weird, not traditional, like someone that graduate, and different background. So that's where I feel like that, I felt a challenge. I was lucky to get my first work at Ernst& Young because I was
Mhm.
interviewed by someone that understood me,
Yeah.
was very analytic. And when I in the room with people that have analytic skills, it's, that's my comfortable zone. But if it was not this person, probably I would not get that job. And I realized that when I got there that I need to improve those skills and, build, better both to do the communication and also to tell my skills in a way that I don't need to run after, for example, at that time it was recruiters.
Yeah.
So that's how I got into all this rebranding in LinkedIn and, working about
Mhm.
those communication, and in certain point it just become like a fun
Yeah.
stuff to do.
Mhm.
But I feel like that's what drove me to go to this route.
Yeah. Yeah, thanks for sharing that. And it's also really inspiring. You're doing the things that you think you need to improve. You're doing more of it. And for us, sometimes when we see someone's speak on the stage, it's not because they think they're great at speaking. Sometimes just because they are also learning. And it's funny that I also interviewed Kenji. He's a data science YouTube creator. He has a 180K followers now, but he told me he started creating YouTube for the same reason, because he didn't think he's great at public speaking. And look at him now.
Yeah, that's
Yeah.
amazing. And I always, that's maybe like my next step is to do a YouTube
Mhm.
channel. I feel like it's more like a time problem that I don't
Yeah.
have. But if I would have time, definitely I feel like I would pro myself to do something that, again, like I feel like people should be able, like if you want to success, you need to go outside your comfortable
Yeah.
zone and
Mhm.
challenge yourself.
Mhm. Yeah, and then now you think it's fun to build your brand on LinkedIn and come to events like that. You start to enjoy that, and that means you're on the way to get better at it.
Yeah, it's always like I learn every day.
Yeah.
It's literally you learn every day.
Mm-hmm. Yeah, and throughout your career, have you had mentors?
Yes, I had few. So I think that when I started to study at the university, I met a professor from the econ that we became. He was a visiting professor from Israel, and we became friends. And he kind of like guided me about, like the academic world, and he, told me maybe you should think about R. It's more useful than Stata.
Yeah.
And when I started my first job at Ernst& Young, this is about great about Ernst& Young that they have this culture of mentoring. And the first day that when you're joining, you get like a peer
Mm-hmm.
advisor, which
Mm-hmm.
is someone, the same level that give you advice from that perspective. And then you have a manager that from different group that help you
Yeah.
doing mentoring. And I thought it was super useful.
Mm-hmm.
Yeah, now I don't have anyone that I can think about, but I'm mentoring other folks. I think that's my way to give back.
Yeah.
So I have a couple of folks that I meet with them like on monthly basis, and we are talk about their data science journey, and I'm trying to help with some advice or guidance about what they can do to continue their journey.
Yeah. So what do you usually tell them? What's your best advice to your mentees?
I think it's like first thing you need to understand what you want to do.
Yeah.
That's the hardest thing.
Data scientist.
No, even with data science, right? We all know that we want to be data scientists, but do we want to do computer vision? Do we want to do time series forecasting? Do you want?
I want to do the coolest thing.
Yeah, and it's one of the things. The main limitation that we have is time. We want to learn so many things. I have so many books, and it's like you look at it, it's next to you on the table, and like, oh, I can read it in if every day I would spend an hour, I will finish it in 2 weeks.
Right.
And it's still there for 1 year.
And think about it for like 10 projects.
And so, that's something super important I learned mainly after becoming a manager is how to scope.
Yeah.
And the stuff that I'm doing in my day-to-day work, I'm trying to apply in my, my personal life from, the perspective of the project that I'm working on. To define milestone, to define clear milestone, to define clear scope, document it, and use a lot of GitHub for this, and try to stick to it. In the past, I used to do like scope creeping, and I used to be very greedy about features. Like you start, I'm going to build those functions.
Yeah.
And then, maybe I should add this and this. Oh, that sounds like a good idea. And then you end up that you are, instead of delivering something that you plan for yourself in 2 weeks, end up like spending a month and a half. And so like, and as time pass, as you have family and kids and stuff like this, that your free time is start to narrow down. So you want to be much more effective or efficient about how you spend your time. So that's I'm trying to also give this advice to other. Define clear goals, scope, define the milestones and timeline.
Yeah, I think it's important you mentioned even within the data scientist role, there are so many directions. But for people who just started or transition their career or mid-career, they feel lost. They don't know what type of data scientist they want to be. What is your advice?
Go explore. Taking courses, you can get exposed to different fields. If you try to map like the core data science area that you have interest, try to take like a couple of courses, try to get your hand dirty by writing some codes and experience what it is to build classification model or what it is to build image recognition model and so on. And then like feel where you feel what is you feel more belong to and go there. It's okay also to be in multiple areas. Like there are the generalists. I feel like I started as a generalist I feel like if you're working consulting, that's the advantage. I feel like in starting in consulting that you get exposed to multiple disciplines. You need to adapt really fast. You are moving to a new client or a new project and you have a new problem that may or may not relate to what you did before. So that's another way to, spending the first 2 years in, something that flexible, you learn a lot, and then you can go and decide, I want to focus on this area and get, be the specialist.
Yeah. I like that because a lot of people think, oh, I have to be an expert and, I need to pick and become an expert. I think I see myself as a generalist. I happen to work in like A/B testing, machine learning, different type of domains, and I enjoy that. I think it's important to have a focus. It's good to have something you're good at. But some people, they just thrive at have multiple interests. They feel bored or confined when they have to spend all their energy in one area. So if you're the type of person, it's totally fine. You can still be successful. I think that could also be your strength, right? For example, a more consulting type of role, or you are very specialized in some business domain, and you can combine those areas together. And I think in companies, especially big companies, there are only limited type of roles. You have this title, data scientist, engineer. But if you think about the bigger scope of life, you don't have to have a business title to define yourself. You can, work on your passion project. If you like to play video games, maybe you want to analyze some data there, even if you are, your title is not a data scientist. So I really like what you talk about. I think not to be limited by a job title or something other people are doing. Look inward to see what you are interested in and pay attention. I think another thing I find helpful is what are something that people give you a lot of compliments on. That might be an area that you want to develop. That maybe you feel like, isn't everybody like that? But maybe that's your superpower.
Yeah, we all have, the area that we are strong at, and we should leverage it to, to overcome where we are weak, right? So that's definitely could be something we need to leverage.
Yeah. So before we wrap up, what is something in your life or your career that you are excited about?
So I enjoy what I'm doing in my career. I think I told you before that when I apply for when I was decide to move to a new role in my previous work and go to the market, I applied for a couple of places. Apple was not, the immediate one that I was thinking about.
Mm-hmm.
And I was more excited about another role that I wanted. It was near my house, related to food industry.
Mm-hmm.
But I didn't get the job in that company. And then I got to this role at Apple. And the reason I got into it was the job description was really talking about time series. It was speaking the language that I felt like, I felt connected.
Yeah.
It was a really good job description. And I was telling to my wife, I feel like going to apply for this. And he told me you don't have a chance.
Mm-hmm.
The perception that you need to referral to. But I applied, and without, understanding what is Apple. And when I got there, it's the only thing I remember the moment I entered to Apple Park and I saw, this magic. And it was I think it changed my life. It's nothing that I build on to get. If you asked me 4 years ago about it, I wouldn't imagine that I would get here and where the position I'm be today. Mm-hmm. So I'm really excited about what I'm doing for my day-to-day to work. Excited about other stuff in family and that's important stuff to balance between the two.
Yeah.
And also excited about the open source project that I see other people are doing, and where it's going. This type of how it changed the world in many sense. So yeah, I feel like there's more to come. And I'm looking for other exciting stuff that I have in my list that I don't have time, I'm playing with Raspberry Pi and this type of toys that I really, really want to do. And probably I will, when my kids will be old enough, I will spend time to teach them and for me to play with. But yeah, I feel like there's a lot of things happening at the time.
Mm-hmm. Yeah, that's very exciting. And for people who want to find you or follow your future project, where can they find you on the internet?
So I have LinkedIn and Twitter. I'm there. I have obviously my GitHub is very active. You can find all my main projects are there. I have Instagram that focus on data visualization. We didn't talk about it much, but I.
Okay, what is your Instagram handle?
I think it's Rami _Krispin. I don't remember it.
Okay, we can link it in the notes.
But I it's something relatively new that I opened, I think, a year ago,
Mhm.
and it's like all my data visualization stuff are there.
Yeah.
I love data visualization.
Mhm.
I have a weird hobbies. I got into cartography.
Mhm.
This is the art behind data visualization of maps. I'm starting a course
Wow.
soon about cartography. It's not related to my work, but
What is it?
cartography. I probably not pronounced it correctly.
What is it?
It's data. It's a mapping. It's all the data visualization behind mapping.
Uh-huh.
And if you go to Instagram, there's a lot of group of people that
Mhm.
doing amazing stuff about visualize maps. It's very inspiring, and I want to learn it. So that's in my to-do list as a hobby. That's not one of the things that it's still data, but it's hobby. It's not related to my work, but I super interested into.
Yeah. That is very exciting. And also, people can find you on like LinkedIn or
Yeah,
Twitter.
yeah. I'm there. I'm open to connect with anyone in LinkedIn. So
Mhm.
social media and
Cool.
GitHub. Yeah.
Yeah, I will link in the notes. Um, it was great to have you on the Data Scientist Show, and I learned a lot about your career journey and appreciate the tips for time series. Thank you. And if you've been enjoying the show, don't forget to subscribe to the channel and give me a 5-star rating. See you next time.
Thank you.